All right, picking up at C here. So if we look at this function, I should note discontinuity at x of -1. So that's important. All right, I'm going to go and take the derivative now. We get, all right, derivative of the top times the bottom minus the top, derivative of the bottom over the bottom squared. And this is going to simplify to 1 over x plus 1 squared. Okay, so if I'm asking where's that derivative equal to 0, and where's that derivative undefined, and f is defined, notice if we ask where the derivative is 0, it's never 0 because the numerator is 1 there, it can't be 0. If we asked where the derivative is undefined and the original function was defined, there's still none of those because the original function was not defined at -1, so I can't take that as a critical number. There are no critical numbers here. But that's okay. That can happen. When I go to do my number line chart, remember I do have the discontinuity at -1. And that is a place where you could have changes in increasing and decreasing, but let's see what happens. All right, then we note that that is a discontinuity. All right, so what we have here is, let's take a number less than -1, so -2. Well, realize the derivative over here is 1 over x plus 1 squared. That's always going to be positive. Doesn't matter what numbers I put in. So it's going to be positive there, and it's going to be positive there. All right, so, and the other thing is, there's no changes in increasing and decreasing, so there's no relative max or min. -1 could not be anything, no matter what happened there, because it's not actually a point on the graph, it's a discontinuity. All right, so we just note that f is increasing there and f is increasing there. And so we could say f is increasing on -infinity to -1 and -1 to infinity. Now we shouldn't actually say -infinity to infinity because at 1, the function isn't even defined, so we wouldn't want to include that anywhere. It's not decreasing anywhere, and there's no relative extrema. So that's all we have. All right, let's take a look at these problems here because it'll give us some good guidance on how to deal with the derivative telling us about the original function. So what's been given here is a graph of the derivative, and we want to tell where there are any relative max or min or where the function's increasing or decreasing. So we want to do the same thing as before, except we haven't been given the function, just the graph of the derivative. So what this is going to allow me to do is I'm going to use this to make my derivative chart. In fact, they've given me more information than I need. So I'm going to say, all right, on my derivative chart, I would put any place that there was a discontinuity or critical numbers. Well, I can see that the derivative is 0 at 2 because it's at 0 level. So that means that that is a point that should go on the derivative chart. Realize that's not where the function is 0, that's where the derivative is 0 because this is the derivative graph. All right, so then what would I do for the equivalent here of plugging in a number less than 2? Well, just look at all the results of the function when you're less than 2. The function's always, the derivative is always negative. And then when you're bigger than 2, your derivative function is always positive. So I end up getting the chart there that tells me my usual things like f is decreasing there and f is increasing there, meaning 2 must be, it was decreasing and then increasing, so 2 must be a relative min. All right, so if I summarize that, f is increasing, f is decreasing. All right, so it's increasing on to infinity. It's decreasing on negative infinity to 2. Relative min at x equals 2. All right, so notice what I can't do. I can't actually find out the y-coordinates of the relative min because I don't have the original function. So that's what I'm left without here. All I can do is say that the relative min occurs when x equals 2, but I can't figure out a y value. I don't have the original function. All right, here's another one like that. All right, so again, I'm given the graph of the derivative. So what I want to do is basically recreate my chart using this information. All right, so I'm going to find all the places where the derivative was 0. So that looks like it's here at -1, at 0, and at 1. All right, then I want the sign of the derivative. Well, when you're less than -1, the derivative is always positive. When you're between -1 and 0, you're always negative. Between 0 and 1, positive, and after 1, negative. All right, so I will be able to put together my increasing, decreasing based on that, and I'm also able to see that we have a couple of things happening here. At -1, it was before it was increasing and then decreasing, so that must be a relative max. At 0, it was decreasing and increasing, a relative min, and then at 1, a relative max, increasing then decreasing. Okay. So if I want to summarize all of that, f was increasing, f was decreasing. All right, f was increasing here, negative infinity to -1, and 0 to 1. It was decreasing -1 to 0, and 1 to infinity. Relative max, well, there were 2. X is -1 and x is 1. And a relative min when x is 0. Okay, so I was able to say almost everything from before. The only thing that I couldn't do is I couldn't give y coordinates to the max and mins, but that's okay.